Imagine you had a single report card that could grade both a human pilot and the AI flying right alongside them. Sounds pretty out there, right? Well, today, we're diving into a fascinating new metric called SDR-HELMETA that's designed to do exactly that, create one universal standard for performance.
So let's just start with that central idea, that really big question. What if we could actually score a human expert and a super sophisticated AI on the exact same scale, using the exact same rules? It's a game-changing concept, and it's what we're going to unpack today.
And the proposed answer to that question is this new framework, SDR-HELMETA. So let's break down what it is and how it manages to act as this truly universal report card. Okay, so what is it exactly? Well, the key phrase you got to know is substrate-agnostic. It's a fancy term, but all it means is that the system doesn't care if the brain doing the work is made of silicon chips or human cells. It just measures two really important things: capability, what you can do, and efficiency, how well you actually do it.
And that brings us to the two pillars holding this whole system up. It all boils down to these two simple but powerful ideas: capability versus efficiency.
The best way to think about this is with a car analogy. The composite score, that's your capability. It's like your car's top speed. It's the absolute max you can do. But the SDR, which stands for signal-to-drag ratio, that's your car's miles per gallon. That's all about efficiency. I mean, you could have a super fast car, but if it guzzles gas to go a single mile, is that really peak performance? This metric looks at both.
All right, let's dig into that first part, the capability score. It's not just some random number. It's actually built from 8 different performance areas, or what the framework calls the 8 axes.
So this composite score is a weighted average of these 8 axes. And to really get a handle on what it's measuring, it helps to group them into 3 main categories. First up, we've got the axes that measure the quality of thinking and accuracy. There's grounded accuracy, which basically asks, is this right and can you prove it? Then there's reasoning quality, is the logic you use to get the answer sound? And then there's calibration, which is super interesting. It measures how well your confidence matches your correctness. In other words, are you as good as you think you are?
The next group is all about how you perform when things get tough. Robustness measures how well you handle stress or confusing information. Then you have tool use efficacy. Pretty straightforward, right? How good are you at using your tools, whether it's an AI using a software API or a person using a map? And of course, there's safety. This isn't just about avoiding mistakes, but also about not being so overcautious that you can't get the job done. And rounding out the capability score are the last 2 axes. Efficiency is all about resource management, your use of time, energy, money, you name it. And finally, reproducibility checks for consistency. Can you get that same great result over and over again? So you see, when you add all 8 of these up, you get a really complete picture of what something or someone is truly capable of. Okay, so that was capability. Now for that second number, SDR, the efficiency score. It measures your signal, which is your good, useful work, against any drag that got in the way. For an AI, drag might be a slow network connection or having to rerun a calculation. But for a person, it could be things like fatigue, stress, or interruptions. It's a really smart way to quantify all the little things that get in the way of a perfect performance.
Okay, that's all the theory. But how does this actually work in the real world? I mean, how do you measure the exact same things for a person and a piece of software?
This is where you really see that universal but tailored idea in action. The what you're measuring, say tool use efficacy, is exactly the same, but how you measure it is totally different. For an AI, you'd look at things like API success rates from a log file. For a human, you might use decision cards or planning rubrics. The core principle stays the same, even when the data sources are worlds apart.
And check this out. Here's a real example from the source material. On the left, a synthetic system. On the right, a human operator. Now, if you look at their individual scores, like for accuracy, they're a little different. But once you run it all through the weighted formula, their overall capability, that composite score, is almost identical, right at 89.5. And look at their efficiency scores. They're just a half a percentage point apart.
So when you visualize those final scores, you see something pretty incredible. On both capability and on efficiency, the human and the AI are performing at pretty much the exact same level. This is it. This is the promise of SDR-HELMETA in action, a true apples-to-apples comparison.
So this is all really cool tech, but what does it actually mean for the future? Why does having a metric like this even matter?
Well, the impact could be huge. For the first time, a manager could have a common language to talk about the performance of their human teams and their AI tools. You could pinpoint exactly where each one needs to get better. It also allows for something called mission tuning, where you can reweigh the scores. So for a surgeon, maybe safety is weighted way higher, but for a graphic designer AI, maybe it's reproducibility that matters most. It's a path to targeted improvement and could even become a global standard.
And this isn't just some abstract idea. The creators have a very clear roadmap to make this a real-world standard. It starts by publishing everything open source, then proposing it to official standards organizations like the IEEE or ISO, and finally, releasing the tools and dashboards so that anybody can use it. This all points toward a future where we can measure performance, whether it's human or AI, with unbelievable precision. And that leaves us with a really profound question to think about. Once we can score absolutely everything, what do we, as people, choose to value the most?